Translations. A translation is a transformation in a plane that maps all points of a pre-image to corresponding points on the image by the same distance and in the same direction. So we can go up a certain number of units and over to the right, in this case, a certain number of units. And they're always going to be the same from A to A prime, from B to B prime, and from C to C prime. So the mapping that shows here below is from triangle ABC to triangle A prime, B prime, C prime. The mapping that is shown below is indeed a translation. The corresponding points are equidistant and in the same direction. This means that the distance from A to A prime is equal to the distance from B to B prime, which is equal to the distance from C to C prime. And that all of these distances or line segments created by the translation are parallel to one another. This mapping is a translation that also produces a congruent image. So segment AB is congruent to segment A prime B prime. Segment BC is congruent to segment B prime C prime. And segment AC is congruent to segment A prime C prime. A translation also produces congruent angles within the image. So angle A is congruent to angle A prime, angle B is congruent to angle B prime, and angle C is congruent to angle C prime. A translation preserves distances and angles. For example, remember on previous slides we had that angle A was congruent to angle A prime. We had that angle B was congruent to angle B prime, and we had that angle C was congruent to angle C prime. And similarly, segment AB is congruent to segment A prime B prime. Segment BC is congruent to segment B prime C prime, and segment AC was congruent to segment A prime C prime. Therefore, we have congruent triangles here. So we can also say that triangle ABC is congruent to triangle A prime, B prime, C prime. So far, so good. But if I'm given these two triangles, how do I prove them to be congruent based on using transformations? That's made possible through analytic geometry on the Cartesian plane. A grid can be superimposed over figures to allow for further inquiry. Let's come up with an explanation that predicts where any point on the triangle ABC is mapped to its corresponding point on triangle A prime, B prime, C prime. Of course, we can use the vertices of triangle ABC as representative points. And with the aid of the Cartesian plane, let's describe the translation point by point from A to A prime, B to B prime, and from C to C prime. To get from point B to point B prime, we moved up 4 units, and to the right 9 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, to arrive at B prime. Will this also explain how we get from point C to point C prime? Take a moment to pause this video and think about it, and when you're done, unpause it. It actually does. To get from point C to point C prime, we again move up 4 units, and to the right 9 units. Will this also explain how to get from point A to point A prime? Just as in the last slide, if we count up 4 units and to the right 9 units, we do indeed get from point A to point A prime. So we have shown that each pre-image vertex is translated to each image vertex by translating up 4 units in the positive y direction and to the right 9 units, or the positive x direction. While strictly speaking, we need to do that for every point, not just the vertices. But we can be confident that once the endpoints of the segments coincide, so will all of the points in between them. The mapping that explains this translation can be captured symbolically in the following way. We have capital T for translation, with the units of 9 and 4, because 9 represented the number of horizontal units that we're moving, and 4 represented the number of vertical units we were moving. And we're putting this in what's called vector notation. where we have these special parentheses that look like a less than and greater than sign on the keyboard with the x direction as the first coordinate and the y direction as the second coordinate. So we have this translation of +9, +4 in vector notation of triangle ABC will give us triangle A prime, B prime, C prime. And again, we're saying T is the translation, that's a function that maps point to point, any point xy on the graph of triangle ABC, and it gets mapped x plus 9, y plus 4 units. Another way you could also see a translation showing is going from x comma y with coordinates to x plus 9, y plus 4 for our example that we have here. There are also interactive graphics and activities that are out there. Here's a link to a Desmos activity where you can show that the translation by HK units results in x comma y going to x plus h comma y plus k. So let's actually go over to that really quick. If you wanted, when you click on that link, it'll show up sort of like this. So what you can do is you can make it be a little bit bigger and darker if you'd like. And you can also elect to slide it over so that you can see all of the translations that are going on. So if we actually press the play button, we can see that we're going back -10 all the way up to where h is +10. And as h is changing, that's representing the horizontal translation to the left or right of our L shape. And then if we also play K, we can see that it changes the y coordinates, or how high and low our L shape goes.